Composer is a powerful dependency manager, much like Bundler for Ruby or NPM for Node.js. All of these systems help developers share code they have built and implement shared code. Composer works in a very similar way. You can specify exact versions of the code that you would like to install. This helps ensure that you don't accidentally get major updates which could break your application, but still get bug fixes and patch improvements when you run Composer Update. Composer is available from getcomposer.org, and if you click on the Getting Started link down here, we can see installation instructions for popular operating systems. Number 5 here we have installation for Windows, and at number 4 here we have installation for StarNix. It's a bit of a confusing name, but it means that these are the instructions for OS X, Linux, and any other Unix-based system. We already have Composer installed in Workspaces, and we can access it using the console feature. If we go back to our workspace, we can take a look. Now we haven't used console before, but we can access it from View, Show Console. You might recognize this as looking very similar to an OS X or Linux terminal, and it is. It works in very much the same way. Now, from here, we can check that we have Composer installed just by running the Composer command. And if we see information like this, then it means it's installed. Let's pretend for this lesson that we're building an application that requires reading files from a zip file, and maybe in the future, it also needs to support things like Amazon S3 or FTP drives. That would be rather complicated to write ourselves, but luckily we can just install the FlySystem package from the League of Extraordinary Packages. Now, to do that, we simply run composer require league/FlySystem. Now what this will do, if there's no composer.json file already, it will create one, otherwise it will append to it, but we don't have one, so we can assume it's going to create it. When we run this, it will ask us which version we want. Normally, it would be a bad idea to specify any version at all, but for now, it doesn't really matter, and we can make it more specific later. So we put star, it just means get me any version you can find. There we go. Looks like it's installed version 0.56. And it's just suggesting a few other packages that we could install if we wanted to, but we don't care about those. So if we look with ls, we'll see we have some new files. Let's refresh our workspace files and see what we've got. So as I mentioned, a composer.json file has been created, and inside we just have some basic JSON with an array of stuff. This array we have require here, which is where we list all of our dependencies. And on the left we have the names of our dependencies, and on the right hand side is the version. So as I said, it's a little bit vague at the moment as to the version, but we know that it's installed 0.5.6. So why don't we just say 0.5. That means if updates come out, then it won't completely break our code. Composer's also created a vendor folder with this autoload.php. We'll look at that in a second. Composer, which you don't need to look at, this is some internal logic. And it's created the League folder with our FlySystem package. And this is where all the code for FlySystem lives, especially in the source folder here. So this is all the code that makes FlySystem run. We haven't had to copy and paste anything or edit anything, it's just straight in there. Finally, we can see a composer.lock file has been added. This is similar in theory to the composer.json file, but it contains much more specific information. Unfortunately, we can't preview it in Workspaces, but it contains information like, was it installed from Git, or was it downloaded from a zip file? If it was downloaded, what was the exact checksum, so we can make sure that we're using the exact same versions as each other. You never want to edit the lock file, but whenever you run Composer Update, .lock will be updated, and you should commit the lock file. So, with Composer installed and our new dependency FlySystem available to use, let's have a look at how it all fits together. So in previous versions, we made our own Bootstrap file, which contained our own autoloader. We don't need that anymore because we can just include the vendor autoload.php file like we're doing on line 3 here. This includes Composer's autoloader and means we don't have to worry about autoloading at all. As a side note, require is exactly the same as include, with the added benefit of if it can't find the file, it will error. So if you run your code and it says line 3 failed, require could not find vendor/autoload.php, then you know that you need to run Composer install. So let's move this console down a little bit so we can look at our code better. Okay, we've got some new stuff here. On line 7, we have use League FlySystem file system. This avoids us having to reference the entire class name with all of its namespace prefix each time we use it. We can now just reference file system and PHP will know which class we mean. On line 8, we have another use statement, which lets us alias the zip class to the global space. This means we can reference adapter and not zip, which is a very common name and might conflict with something else. On line 10, we are instantiating an object as an instance of file system, containing an instance of zip as a constructor. That zip class is then taking the location of the zip file as we want to read as a string argument, and that location is in the current directory /archive.zip. Then, line 13 uses a file system object method named listContents, and we output everything in some HTML at the bottom. This HTML makes an unordered list on line 24, and proceeds to loop through on lines 25 to 27 down here. This little for each will go through our contents, and then make a content variable for each item it finds. Finally, line 26 outputs a few values from the content array. The type will say file or directory as a string, and the path value will be the name and location of the file inside our archive.zip. So let's run this and see what we get. And there we have it, a complex task made super easy just by installing a Composer package. I promised we would look through PSR4 as part of Composer. Well, now that we know how to use Composer, we can look at how we build components with it. We'll use PSR4 as the standard to do this, along with a few other standards. All of that will be covered in the next stage.